Right. Okay, I'm going to switch now to the presentation. Pardon? It's not working all of a sudden. It was. Right. Good afternoon, everyone. My name is Jan from Controls Testing or Controls Group. Thank you very much for joining, whether you are live in the audience or joining us remotely. So I appreciate your time. It's quite late in the evening, and I know it's here today for you. What I'd like to do is, before we talk about the main topic of the presentation, is very quickly go through the company that I represent. Okay, so it's a company called Controls Group. We are leader in the manufacturing design of laboratory testing equipment for civil engineering application. So effectively, construction testing equipment, construction materials, we make the equipment to test it. We've been around since 1968, so over 50 years old, one of the pioneers in the industry, and therefore of expertise and history in that respect. We have more than 4,000 products in our range, over 400 distributors, and 6 branches scattered around the world. What we do as a company, we start from the initial conception to the after-sales service. So it is the conception, the design, the manufacturing, distribution, after-sales. So we are involved at every stage of the process, meaning that we have complete control and complete knowledge and understanding of what we are supplying to you, the customers and the companies doing the testing. Controls as a company is involved in 3 divisions. And these divisions cover the 3 main areas of testing. One being controls, which covers the concrete, the aggregate, the cement, general laboratory, and steel testing. And that actually was the very first activity of controls. Controls then got involved further into the road testing, asphalt and bitumen, and actually the advanced asphalt section is called IPC Global. Finally, the 3rd division in which we are involved is the soil mechanics and rocks, which is headed by a company called Farrell. All these 3 companies effectively represent controls, and they are all controls. It's just every division has a different name, simply because these companies existed in the past, and we are just continuing the name, even though they're part of controls. So like I said, the control side is aggregate, cement, mortar, concrete, general lab, soil and road base. So we're talking here about the basic, and then steel rebars. IPC Global is asphalt mixtures and bitumen, which will be the topic of today. And then the soil mechanics, which is rocks and soil. Obviously, rock is a very hard soil, but it is still a soil. We get involved in dams, hydraulics, roads, bridge challenges, every activity which requires building, we will get involved in the testing part of it, whether it is power stations, irrigation schemes, etc., etc. And the companies that are involved in this project are typically testing houses, government ministries, and the education system. All have a need for testing, all have a need for understanding civil engineering testing, and therefore all companies, there are all institutions which benefit from controls testing equipment products. We provide robust testing solutions. We've been around for 50 years and more, so we have some experience in this matter. We are very flexible on the commercial side and the technical side. Very good customer service, and we'll discuss that a bit further later. And we cover the whole range of equipment, but also, that means that we are able to provide equipment for the very simple tests like gradation, sieving, etc., up to very advanced and dynamic fully automatic systems for soils, asphalt, or concrete. So simple and very advanced testing methods. We have a team of dedicated engineers in Italy and in UK, and actually all our branches dedicated to provide support, technical support to the to our network of agents, but also directly to the market in terms of installation, advice on how to use equipment and how to maintain the equipment as well. We have over 100 distributors worldwide, and in Ghana, we're presented by the company Tectonics Engineering and Consultancy, who are based in Accra. And these are people who have been trained on the technical side by controls staff, so they have direct access to the source. Just going back on here, we also have branches, controls branches all over the world, well, all over the world, in the major part of the world. Italy, Spain, France, UK, Poland, Mexico, US, and Australia. I come from Controls UK, who is, by all intents and purposes, the African branch, looking at all the English-speaking African countries. We focus on quality. All our equipment is manufactured to be able to test to standard, to the international standard, being American or European standard, which are the main two standards worldwide, and every other standard is kind of a variation of these two. We are also accredited to perform calibration of the machines, and there you go. So just a little bit about controls, the main part of the concrete side of it. We have equipment that is manufactured by controls and providing effectively quality, advanced testing, standard testing, and all the general laboratory equipment which you would find in most labs. As explained before, we get involved into all these materials, the testing of these materials, and you can see an example of the type of machines that we would supply. That's an example of concrete testing machines, going from the very basic crushing capability to the fully automatic multi-capability. We're talking e-modulus and permeability, etc. Computer control machines with capability to have additional frames as well attached to it. So that's from a very simple test to the fully advanced, getting involved in research as well. The range of raw materials testing equipment, so we're talking about the basic or the traditional testing, which is Marshall, Proctor, CBR, and the basic binder, asphalt, base, and aggregate testing. And we are a one-stop shop as a company. We have all the other accessories like the beakers, the sieves, the rulers, etc., and the molds which are necessary to perform these tests. or IPC Global, originally was an Australian company, still is, involved into the advanced asphalt and bitumen testing. So that was sample preparation, dynamic test, and advanced bitumen testing. They've been acquired by Controls in 2014. So all their knowledge, the capability, and the technology is now part of Controls. And they are presenting, or they are the asphalt and bitumen advanced, or advanced asphalt and bitumen side of Controls. This is some of the equipment that you would find manufactured by Controls under the division of IPC Global, and this is all asphalt testing equipment, and we will go into that a little bit later. And this is the type of equipment related to binder or bitumen testing. Wickham Farrads, a solid mechanics site, acquired by Controls in 2004. That's a British company. That was one of the pioneers in soil testing, and now part of the Controls group for like 20 years now. Again, getting involved in rock testing, dynamic testing, traction, obviously one of the biggest part of the soil mechanics, and the traditional testing and consolidation as well. So this is some of the equipment that you would find related to Controls and soil mechanics testing. One of the latest innovation in Controls technology is the introduction of the EMS, which is electromechanical circle actuation technology. In other words, is replacing a hydraulic ram by an electric motor. The advantage of doing this is you no longer have oil, an oil pump, etc. So it's a silent technology, it's environmentally friendly, low maintenance, high performing, low operational cost, and easy installation, very much plug and play as close as possible. We don't sell the product, we provide support, calibration, assistance and training on all our equipment, but also because of our 50 years of experience, although we are not teachers, we are not civil engineers, we have been exposed to the industry for so long that it tends to, be part of our DNA now. So this is why we're able to provide training not only on the equipment, but also on how to perform the test. However, we are not instructors. We do not have the accreditation to do that. But our knowledge certainly gets involved at that level. And that is reflected in the after service when the engineers are visiting your lab. They are able to provide you with advice and support on your existing equipment and the type of equipment that you would invest in to increase the capability and performance of your test lab. Finally, we have a catalog. We are working on a new catalog version. This is the latest edition is 2019. So it's quite old. We should have a new catalog end of this year or early next year. Having said that, the best source of information is through our website, which is continuously updated and gives you information on the latest products and videos and user manuals, etc. Okay, thank you very much. I will now move on to the main part of the presentation, which is the asphalt and bitumen testing. Where is my notes? I hope everybody is still online. I will start as we go. I will speak louder and louder so people don't fall asleep. I might even start putting faces. Okay. You see that it's not showing on the TV, so I don't know.
Let me share that one.
I need to share this one as well.
You want to share the other one?
There you go.
No, it's come.
Perfect. Right, sorry for those who couldn't see the proper screen. So now we're going to talk about understanding the Superpave type performance-based testing and design fundamentals. So that is the topic of today. I'm not going to go into the next slide because ultimately you've seen it before. It's just a quick introduction of controls as a company. And the company division of controls that is involved in Superpave mostly is IPC Global. So, straight imaging, how you could inspire and engage with the decision makers in your country to invest in the technology and know how that could make a real difference to people's lives. That's a bit of a pompous sentence, but we're going to see the relevance of that statement in the next few pages. And we go straight to the heart of the matter by asking that main question. Think about the worst roads that you've been traveling on. And these are bad roads, and we've all been on roads which were even worse than this. And obviously, it's not a good situation. We do not want to be traveling on roads which are in this condition, because apart from anything else, there is a cost to bad roads. Okay, that's the issue here. There is a financial cost to this issue. Early road failures, so there's a cost of repair or a cost of construction. Maintenance cost, because they just need to be continually maintained or repaired. Traffic delays, and that is such a big issue in all the major cities in Africa. A lot of the roads, because of this really poor state of the road, effectively the traffic is just not flowing as it should. And as we know, major cities are extremely congested. So that is just adding to the problem. Increased death and trauma from RTM means road traffic accident. So bad roads, a lot of traffic, it's a recipe for disaster. But it also affects the drivers themselves. Vehicle wear, damage, your tires, your suspension, your tracking, etc. All that gets affected by the bad roads, and as a result, it's difficult for people to access education, difficult for the health service, ambulances, etc. So this is not something that we want to be living in on a day-to-day basis. It should not be an accepted part of our life. And finally, ultimately, this is costing money to everybody, to the government, to the health service, etc. And that's money that we could save, by having roads that are not going to be an issue. We could effectively use that money elsewhere. So that's the important part of this representation as well. So, what is the importance of asphalt characterization? We need to understand. To get a good road, we need to have a good ingredient in that road. Just like when we're baking a cake, we need to have the right ingredients to be able to have a good cake. That's not the only thing that we need to work on, but that's definitely a starting point. Asphalt, bitumen, and binder. So if we look at the liquid part of the asphalt, which is the binder or bitumen, it has changed over the year. The oil economics and global factors have affected the bitumen characteristic, which is effectively the source of the bitumen. Used to be a few countries around the world. Having said that, now many countries supply and produce their own bitumen. So the quality, the consistency of the bitumen itself and the characteristic do change. That means that you have to be able to characterize that bitumen a little bit better, because every bitumen tends to be a little bit different from one another. So that's one thing. The other thing is the consistency in relation to the refining process. More and more, the refining process is changing. It is removing a lot of characteristics from the bitumen to be used for main applications. And what is left is the bitumen that's used in the roads. So again, the consistency of the quality of the bitumen is changing. And finally, to be able to cater for the cost of bitumen, because that's the biggest cost of asphalt is the bitumen content. That's the most expensive part of the final product. Then companies are effectively trying to modify the bitumen with additives and polymers, not only to replace the bitumen content, but also to give it greater performance based on the application. So, type of modification that you would find in your bitumen is recycled asphalt. So the asphalt itself is recycled and reused into the bitumen. You have marginal materials, which effectively are materials that you would find locally and not necessarily of the same quality than the materials that you would have in your asphalt. Especially the filler side of it. And then finally, recycled tire rubber, which is more and more used, actually quite commonly used now in the asphalt industry, to be added into the asphalt itself, into the asphalt mix. So it's important to consider all these in your testing process, because these were not in the old asphalt testing before. Therefore, the condition of your test has changed because the material that you're testing has evolved, has changed, is no longer the same as before. So why do we test? Why do we actually do the test? Because the two main road failures are rutting and cracking. Obviously, rutting as a whole has lots of different types of rutting, and mostly the cracking. So rutting is a physical wear, whereas cracking is more related to the resistance of the asphalt to environmental conditions. You know, the rain, the heat, the cold and hot, water infiltration, etc. Okay, the climate. So in cracking, you have different types of cracking, and rutting, you have different types of cracking. All of the road failures, the main road failures, are under the umbrella of rutting and cracking. So we need to understand what goes into the roads to be able to perform better resistance to rutting and cracking, to characterize the materials, to establish a structural design, to be able to perform QCQA test, identify inferior mixes, and to carry out forensics in case of conflict after failure of the roads. So it's really important to know what goes into your asphalt. In the 1980s, a group of road professionals identified that there was a real increase in traffic volumes, a real increase in traffic loads. So not only the amount of cars and trucks on the road, but also the weight itself. And then the use of new pavements, as we talked about with the new or different bitumen. And that resulted in a dismal performance of highways. So roads failed them. And they effectively come to a point where they said, well, enough is enough. We don't want to have to live with such bad roads. We know that there is going to be more cars on the road. They're going to get heavier. Traditional mixed design methods like Marshall and HB could not provide any information on the performance properties of asphalt mixes. So they identified that the tests that we're performing right now are not adequate to reflect the real life situation, what asphalt actually goes through. So in 1987, they launched a strategic highway research program, or short for SHARP short. And one of the program, or part of the initial part of the program, was to do a simulation of the traffic growth in just over 30 years. And as you can see, it went from green to a lot of red. So this is, we're not in 2035, but effectively the trend is it's just going to grow, it's not going to reduce. And they decided that we cannot keep the roads, build the roads as they are, because they're not going to survive for 20 years as they are. The traditional tests were simple, but they were not really no longer accurate. They give limited information of asphalt materials. If you look at the Marshall test, the principle is you take a sample, you compact it by a specific number of blows, and you measure it at one specific temperature, and you're measuring two factors. One is the stability, which is its resistance to load, and the other one is the flow, which is the deformation under that load. And based on these two factors, these two parameters, the whole beam of roads were designed. That means we're taking two data and then putting these formulas or the results into loads and loads of different formulas that give you an estimation of how your road will behave in the next year at the point of construction, etc. The issue with that is you are putting many safety factors in your formula. That means that you don't have a real understanding of how the road will behave in real life. It's just an estimation. And that's part of the problem. That's one of the problems, that we're just hoping it's going to be okay. Traditional tests is what we know, the Marshall test, the Marshall compaction, etc. And then designing roads based on these two parameters, these two main parameters. Performance test is the other way around. It's actually putting it to the test as well. If you're going to build a road, let's test that road, let's see how it behaves in the lab, simulate the real life situation in the lab. So for a traditional test, they're not related with real conditions, whereas we're simulating in close way the real ones, but inside the laboratory, so it's controlled condition, and the advantage is much quicker, much cheaper to replicate than to build a road and wait for the results. Traditional tests are empirical. They do not have a direct connection with the real one. It's just data. It's just a set of numbers. They're not actually showing you a graph of how the road will behave under rocking. It's just a number. It's very easy to get it wrong. And performance related, you measure the parameters, which are the same parameters measured on site. And actually, it's a physical test. Traditional tests do not have the ability to foresee the behavior of asphalt. Whereas, obviously, the performance test, it's all about being able to forecast how it works, because the conditions that you recreate in the lab are extremely flexible and allow you to recreate a situation right when the road is built up until 5, 10 years plus of service. All that in the lab. So the performance test will simulate the real behavior. It will cover a wide range of application, the force, the duration, the repetition, and temperature, which is something that you cannot do with other tests. And obviously environmental condition and changing environmental condition. Able to evaluate viscoelastoplastic behavior of asphalt, that's a very long name, but effectively is deformation considering the load against time until permanent deformation. And from laboratory testing, that's probably the most important sentence on that slide, laboratory testing, it is possible to forecast the pavement behavior. So we are then going to the Superpave performance testing. Advantage of Superpave testing is reduced construction cost, because we are testing, and when we have a right fix that is applicable to the design or to the road that you want to do, then you know you're going to get it right first time. Reduce lifetime costs, because you don't need to maintain the road any longer, so much in any case. It doesn't mean that the people will drive better, they will still have accidents, they will still, sing too loud and lose concentration, or have a fight. And then have a crash, but that we can't control that, and that will damage the road. But in any case, the road will be lasting longer. Low carbon footprint, because there's less energy used in construction or reconstruction and traffic congestion. Reduce fuel use, that's debatable, especially since now we're more and more into the electric side. In any case, better access to education, healthcare, economic development, etc., etc. The delays, all the things which were a problem before, all of a sudden, the application of Superpave testing in the design of roads is being reduced. So, performance-based pavement design laboratory. So obviously, we are doing all the simulation in a very controlled environment, which is the size of this where I'm walking now, as opposed to having a massive road on which you test forever. Now, we believe in developing technologies that are within the grasp of most engineers, and that's the important bit. So, initially, or early stages, machines were created to replicate and to simulate real-life situation. But these were extremely complicated machines, very inflexible, and not easy to operate, and therefore effectively very expensive as well. So people just didn't tend to use them. It was, effectively becoming a bit of an elite area of the testing. However, at Controls, we want to democratize the test. This is what it's all about. It's actually bringing it to the people and making it available and affordable. So what are the steps of Superpave mix design? First, we need to characterize the material, to select the right material, binder and aggregates. Then we need to design the aggregate structure, design the binder content, and finally do a mixture performance testing. So let's look at the material selection. In the aggregate selection, so obviously asphalt is aggregate, filler, and bitumen, and I'll go in tiny details later about the filler, but the filler is effectively the marginal material, so we're talking about the dust and the little particles that are smaller than the aggregates themselves. Now, selecting the aggregates is traditional test, Los Angeles abrasion, soundness, water absorption, etc. So we're not going to spend any time on that. That's not necessarily part. It's not a new part of Superpave. It's just Superpave is borrowing these tests, which are very valid, and there's no need to modify them. However, the asphalt binder selection is necessary to do the PG grading, so it's characterizing the binder that you have because of its change of consistency and source, etc. we discussed earlier on. Aging of the binder and the mechanical test on the binder. So really putting the binder through its paces to make sure that it is applicable for the road that you're going to build. And we, of course, have good products that we require to do these type of tests, whether it is the aggregate selection or the asphalt binder selection. So let's look a little bit greater detail the binder selection. So the PG grading is effectively just what it is, a grading. So it gives you an idea of what type of bitumen you're dealing with. You get a sample of bitumen, you do a PG, you do some tests on it, and at the end you will have a PG rate, which tells you, it categorizes. Okay, the first digit is the average 7-day maximum pavement temperature. So you put it through 64 degrees for 7 days, and you see how it behaves, and it gives you effectively a number. So that is, it will behave properly on average 64 degrees for the first 7 days. That specific sample that you've given me, that number will change based on the bitumen sample that is tested. And just going back in, and that number is quite important when you're looking for bitumen that will be resistant to rutting. The second digit, or set of digits, is the other way around. It's resistance to fatigue cracking and thermal cracking, and it's saying how it behaves at low temperature. Okay, but when you have run all the tests that we're going to go through in a minute, it gives you effectively the identity card of your bitumen, which would be the same as me, my height, my origin, my weight, the color of my skin, etc., my blood pressure, whether I'm an athlete or if I just should watch TV. Okay, so what are the tests performed that we use to perform to get the PG rating? Because there are a certain number of tests that you perform to get to that rating. And these are, there are several related to different stages of the binder itself. During construction, you do rutting and fatigue cooking and low temperature cracking test. So obviously you go down in temperature at construction when you're laying the bitumen or you're mixing it with the asphalt. The aggregate is a higher temperature, and then we're considering equipment to simulate or to understand how your bitumen will age over the years. So if we're going to look at the aging first, asphalt binders undergo aging through the loss of volatiles and oxidization. So effectively, when the binder is laid, even during the pouring process or the mixing process, etc., it's straight away aging. It's like boiling water. As soon as you turn the heat off, it starts to go cool. You know, that is just physics. And the binder itself is subject to aging. What we understand in short-term aging is during the construction, the transport, the laying, and the compaction. So post-construction to roughly 2 years. So within the first 2 years, the binder is called, or we verify, called the short-term aging. Long-term aging is when it's been in service more than 7 years. So anything in between is effectively also aging. But certainly up until 7 years, it's not long-term aging yet, but it's no longer short-term aging, so it's middle age, a bit like me. Okay, so RTFO, short-term aging, and PAV, long-term aging. RTFO and PAV are two types of tests, and I'm going to go through that immediately. Short-term aging, rolling thin film oven. So that is effectively the piece of equipment that you will use to understand the short-term aging, how your bitumen behaves within the first 2 years of its life. And I'm not going to go into details, mostly because I don't know how it works exactly. I'm not the engineer, but it's simulation by the combined effect on the binder of heat, air, and time. Okay, and mostly that recreates the binder at the binder plant. As soon as it leaves, it starts to travel, it is exposed to the atmosphere. And the atmosphere will start oxidizing your binder. The cooling will create a specific thicker film on top of the binder, etc. So you're creating this in your rolling thin film oven. And then the long-term aging, it's called the PAV, pressure aging vessel. So that is a machine, and it simulates the long-term aging by the combined effect on the binder sample of heat, pressure, and time. So you actually put your bitumen through a lot of pressure, really, really high pressure, and that will reflect, that will simulate the effect of time. I'm not exactly sure what is the cycle behind it. But at the end of that test, the difference of characteristic between your binder before and after, it gives you information about the long-term effects of weathering. Additionally, there is a piece of equipment called the VDO, the vacuum degassing nozzle. This is a very interesting additional test. When you've done the long-term aging test, the PAV, there is a chemical reaction down to the pressure and the heat and the time, which creates bubbles into your bitumen. So your bitumen ultimately will be spoiled by that test. And many companies want to be able to reuse that bitumen for other tests. There are other tests that you perform within the Superpave test or even within the normal bitumen testing industry. But you want to have a neat sample. So effectively, to perform tests like penetration, ductility, softening point, etc., you need to effectively either get your bitumen back to its original condition or to get a new sample of bitumen. And bitumen is expensive, so people actually want to be able to reuse it if possible. The vacuum degassing oven effectively removes the air bubbles. Again, I don't know the science, how it does it. It's magic as far as I'm concerned, but it does it. And it gives you your bitumen back. So if you do it one test a year, etc., you don't need to buy this machine. But if you are a testing house, your commercial lab, etc., or bitumen plants, you want to be able to not just to waste a lot of your bitumen in the testing. So that machine comes in very handy. So we've done the aging side. So now we're gonna look at the physical test, or the physical test, not anything to do with aging. So for the construction side, we've got a viscometer, a rotational viscometer, to identify the properties of behavior to rotting and fatigue cracking. We've got the dynamic shear rheometer, and for low temperature cracking bending beam rheometer. Obviously, this one may not be so applicable for hot climbing land in West Africa. But I'm going to bore you to death with it in any case. Rotational viscometer. So what does it do? First of all, it helps you identify the first two digits, which is the rotting, or closer to the rotting stage of your road. What it does, it helps you, it ensures that the binder has a suitable fluidity, pumpability, and mixability during the manufacturing and construction process. So it effectively helps you know that how to make sure that your bitumen is going to be suitable for the early stages of the mixing, when you're pouring it with your asphalt, etc. You don't want it to be too liquid, you don't want it to be too viscous, effectively, which is a viscometer. So it's a little bit like a slump test on the concrete. The principle is it measures the torque required to maintain a constant rotational speed at a constant temperature. So the spindle will turn at a specific speed, a set speed, which is dictated by the standard, and it has to turn into the bitumen at a specific speed, and the sample has to be at a specific temperature. So these are the two set parameters, and it will identify how much torque is required to achieve that. Okay, and when you know the torque, you can then determine through the formula the viscosity of your bitumen. Okay, and of course you do that on unaged asphalt. It's at the very early stages of the road construction. Now, other two tests which are related to rotting and fatigue cracking are tests that you can get through your recovered binder. So the DSR and the BBR, and this is a machine, the two machines. So the first one is in the middle, the DSR direct dynamic shear rheometer. And that's for the latest, it helps you determine the last digits of the grading. The purpose is to predict the hot mix asphalt rotting in the pavement life and the fatigue cracking later in pavement life. So it gives you it enables you to identify two specific characteristics. It measures the shear resistance and lag at specific temperatures. So it's a very, it looks like a simple test. You have a pattern, a round pattern, a very small disc, and you have a film of asphalt on it, or bitumen, sorry, and then another pattern is sandwiched between two discs, and the top disc is going to rotate very, very fast, and eventually we shear through friction the bitumen, and it will measure the shear resistance and the lag, so effectively the residual shear at a specific temperature. And the geniuses in the lab will use all that data to be able to identify the shear volumetric properties. And you conduct that test on unaged, short-term aging, and long-term aging asphalt samples, so that it's applicable at all the stages of the bitumen life. And finally, the BER, bending beam rheometer, as the name suggests, low temperature cracking. So again, in the later stage or the second part of the PG grading. It predicts the asphalt binder's ability to resist low temperature cracking. Now, why do we care about this? Well, the problem is a single severe drop or repeated thermal contraction, physical contraction of your binder, effectively will have what's the word? Negative effect on its binding properties, effectively its gluing characteristic. And the principle is it's like a flexural test on concrete beams. It measures the deflection against time at a constantly low temperature. And we do that on old samples or aged binder samples. So we've looked at the aging. We've looked at the viscosity, the rotting and fatigue cracking capability, and then the low temperature cracking. We're now going into other tests which can be carried with recovered binder after the aging process. These three tests are not the ductility, softening point, and penetration. These are standard bitumen tests. They are not Superpave tests. Okay, they're not new tests. They've been around forever, but they are very important as part of the Superpave testing process. So Superpave again has taken these tests. They're not Superpave tests, but they're definitely necessary to be able to perform or to continue on the Superpave process. So we look at the ductimeter or the ductility side, and it gives a measure of the adhesive properties of bitumen and its ability to stretch. And that actually goes back to the low temperature cracking as well. So it works in conjunction with the low temperature cracking, because a binder material having insufficient ductility, okay, it gets cracked when subjected to repeated traffic loads. And then you have water insertion. So it's a real physical issue, and that test helps you identify, effectively, if it's going to be suitable for your activity. So the ductility is in relation to the traffic loads, whereas the low temperature cracking is in relation to thermal activity. But it gives you information about its ability to resist water insertion. And the diagram is very self-explanatory. The ductility is the distance between the original point and the point just before failure. And you perform that test before the reconstruction, of course. So we've seen the ductimeter. Now we're going to look at the softening point, another very important test. Helps to determine the temperature up to which the bitumen can be heated for different road use application. So effectively, we want to make sure how hot your bitumen can be until it starts to lose its properties. A binder that starts to melt means the pavement becomes sticky, and we don't want that. It looks like a complicated test, but effectively it's a film of bitumen with a metal ball on top, and you heat the bitumen. You have a water bath underneath, or well, it's not just water, there's some other thing with glycerin in there, and it makes the bitumen hot. It gets so hot at some point that it goes from a solid state to an elastic state and eventually a liquid state. At that point, that little ball there will fall through the bitumen, because the bitumen is sitting on a ring, just like the wedding ring. Okay, so the wedding ring is full of bitumen, and the ball is just sitting on it. And when it gets too hot, then the ball drops, and you measure the temperature. And at that stage, you know how hot it can become. It can be up until it starts to melt. And you do that before the road construction. And finally, the penetration test. It classifies the bitumen according to its adhesion and hardness. The soft bitumen is used in cold weathers to avoid cracking, whereas in hot weather, the hard bitumen is used since it doesn't get soft due to the heat. And it's a very, very simple test. You have your bitumen, and you have a needle that drops into the bitumen, and you measure how deep the needle drops. Then you do the test again a few minutes later, because your bitumen will get, the longer the bitumen is liquid to start with, and then as it cools off, it becomes harder. So your needle will penetrate less and less and less. And if you plot it onto a graph, it will give you effectively the penetration rate and its ability to identify how quick it sets effectively. It's a set test, just like the cement pipe. And you do that before the road construction. So we've done the material selection now. So we've identified the binder side and the aggregate very briefly. Design the aggregate structure. I'm not going to spend any time on it because it's not within the scope of Superpave, also not within the industry of controls. We are involved in the single aggregate selection, and Superpave also gets involved in the combined aggregate. So when you have all the different type of aggregate, different shape, etc. But this is an area of testing which is not within the scope of controls. So I'm not going to tell you about it, also mainly because I don't know anything about it, because controls doesn't get involved with it. But it's an important part of the testing, but it doesn't touch your side actively. So we've quickly skipped through that. And then we're going into the design binder content. And that's my baby right there. The reference testing machine is the Superpave gyratory compactor. The single most or first piece of equipment any Superpave lab should get. If you or your company decide to equip your lab with Superpave testing equipment, you want to perform Superpave, the very first machine you should get is that. Without this, you cannot have a fully functioning laboratory. Because it's a compactor, but it's more than a compactor. It allows you to control the density. It allows you to make extremely high precision cylinders of asphalt. And it allows you also to understand the properties of the compaction of the asphalt, but in relation to the real life simulation, not like a Marshall test. It replaces the Marshall compactor and then so it doesn't just compact. How it works, and that's the magic, the magical science here, is not only it is compacted, but your sample is rotating at the same time. So it's a dual effect compaction. And it stimulates on-site compaction. Effectively, it recreates in the lab the effect of a roller compactor. Okay, it's integral to the mixed design procedure, so it's very much part of the Superpave design method. It gives you laboratory verification of your mix, and also to make sure that your contractor is doing the right mix, so you can actually verify their mix in your gyratory compactor. You can use this machine on site, and it prepares very good quality cylindrical samples that they want to use for different tests afterwards. Okay, because asphalt cores are used on a regular basis for other tests. Thank you very much. We have two types of gyratory compactor: the gyrocomp, which is dedicated to the contractors. It's a robust and affordable piece of equipment, which is effectively dedicated to a couple of tests, or the main test relating to EN, ASTM, and Asphalt. Whereas the Galileo is the very new technology, very few moving parts, so very long lasting, very silent, doesn't have air compressor. It's got EMS technology we talked about, with electric motor. This one requires an air compressor, whereas this one doesn't, so it's plug and play. And it gives you great ability for effectively it's more flexible than the gyrocomb because it's available to do further tests in the lab or as research, whereas the gyrocomb is dedicated to the contractors who only want to do one type of test. So you only need a machine that is simple in that way. So and that is the main machine to design the binder content, how much binder you put in your asphalt and how it's going to react to the compaction, what is your asphalt going to be. Finally, the mixture performance testing. So we're going to look at equipment that is used to prepare samples and test your mix, so which is the final stage of your Superpave activity. So these are the machine at the end that you will use to test your asphalt on the performance. So to do a performance test on your asphalt. Several machines. We're not going to spend too much time on these two, but probably a little bit more on the last three. Now, every test requires a specimen, and as you can see, the specimens are all different shape and sizes because they are best suited to recreate the test as you want it to simulate a real-life situation. You cannot put a lump of asphalt into the machines and expect it to do the test. You have to effectively condition your sample, your specimen, to fit the machine, to fit the test itself. Because the standard says, for this type of test, you need to have a sample of that size, that shape, that dimension, etc. Okay? So how do you get from your aggregate and binder and your asphalt effectively from here to a very nice looking sample? Well, first you need to get your aggregate and your binder together into what we call the asphalt. Okay, and to do that, we've got controls have a bitumen mix, which is, for all intents and purposes, a big asphalt mixer. Okay, it's fully automatic. The advantage is you get 30 liters worth of asphalt, which replicates the asphalt plants. You know, when you want to test your bitumen or when you want to test your asphalt, you will perform several tests from the same batch. And if you have a small mixer, 5-liter mixer or 10-liter, which is typical asphalt mixer, then effectively you have a limited amount of tests that you can perform because you don't have a lot on the same batch. Obviously, this is 3 times the capacity of a 10-liter, and it's heated at the right temperature as well. So you will have a big batch of asphalt to be able to perform many tests and reducing the margin of error, because every time you do a test on a different batch, then the batch itself is going to be slightly different by nature. So you're removing this uncertainty by having the ability to do a lot of tests from the same batch of bitumen. Obviously, you use this before the shaping of your specimen. That goes without saying. So when you've got a nice lump of asphalt there at the right temperature, all the same, is very homogeneous, very coherent, etc. But you still then need to shape it to be able to get it to the final specimen size. Let's remember, asphalt is aggregates plus bitumen plus filler. Filler is all the little particles that are in the aggregate or bitumen, and they help into the cohesion of the material. As I said earlier on, in the asphalt, the bitumen is the most expensive ingredient of asphalt. So you want to have the right amount of bitumen in your mix to ensure that it is performing as you need it to perform, because a road will be either on a bridge or in a tunnel, or it's a highway or it's an urban road, and they are all subject to different conditions by default, okay? Because of where they are and what traffic they are subjected to. So you also need to have a different amount of binder. Roads in very hot country need to have very elastic binder, and you need to put more or less binder based on the climatic conditions. So you want to make sure you don't have too much binder or not enough binder, and you want to have the right amount so that you minimize the cost of your asphalt. As a, on a commercial side, you want to have it right. You don't want to pay too much or to make it too expensive. So to do that, to actually understand the amount of bitumen in your asphalt, when you don't have the ability to do the mix yourself, for example, as a consultant, you want to check the bitumen content that is going, that you want to make sure that the contractor is using the right amount, is putting the right amount of bitumen in the asphalt. You can effectively reverse engineer and find out the bitumen content via two different types of machine. The first one is the old singing or dancing Pave Lab 50. I'm not going to go too much in detail. I say that every time, and then every time I go into details, but I think it's a great machine. But what it does, it gives you the accurate bitumen content. And in reverse engineering, it goes from the asphalt, and it breaks down every component. It gives you the aggregate content, the bitumen content, you recover your solvent, which is necessary to dissociate the bitumen from the aggregate, and it gives you your filler back as well. So it's a great machine. You put your asphalt sample in here, and it will effectively be in the bath of solvents. The solvent is a toxic liquid, which will dissolve the bitumen and the filler from the aggregate. At the end of that washing process, you will have your aggregate which has been cleaned and which has been dried. Okay? The liquid that's taken out of the aggregate goes into a centrifuge, which will spin at very high speed and remove the filler. So all the physical, the solid particle will be effectively ejected from the mix, go into a filter on a filter paper. And then at the end of that process, you only have the solvent and the bitumen, which go into then a distillation chamber. And through a distillation process, it will separate the bitumen from the solvent. And you have two taps here. One, you will recover your bitumen. The other one will recover your solvent. The solvent can be used for the next cycle. The solvent has actually been cleaned through the distillation process as well. So originally there's a balance here. You put your asphalt sample on here, you measure the weight, and then you measure the weight at the end of each component and gives you a percentage of the content of every ingredient which was in your mix. And the advantage of that machine as well is you're getting your bitumen back. So you can use that bitumen for other tests after, like the penetration, the PBR, etc. So that's another added advantage. The disadvantage of this machine is you have to buy the solvent, which is again a regulated substance. You need to have storage capability for that, etc. But the machine itself, big advantage, however, is that there are no fumes. It's all fully enclosed. You don't need a fume hood, and it's very safe. And as such, the training process and the regulation process is only linked to the solvent storage rather than the solvent use in the machine. The other machine that is available is what we call the Bitumax. And the Bitumax, very simply, is an oven, very, very high temperature oven. And the principle is you put the big advantage in comparison to the previous machine is you do not have the use of solvent. You weigh your asphalt sample, you then put it into the oven, and the oven will burn the bitumen from the asphalt mix. So at the end, what you will have is your aggregate, and you weigh that aggregate at the end. And the difference between the original weight and the final weight is the bitumen content. The big advantage again is you do not have any solvent. It's a very quick process. With the Pave Lab 50, that takes about 40 minutes to an hour. I think this one is about 15 minutes or so. I'm not exactly sure. It's much quicker process, and it's a cheaper machine as well. And there is much less training required because training is open door, weigh your sample, burn it, open door, take it out and wave it. You know, it is very, very simple. The disadvantage is that you have burnt bitumen and filler. So you have effectively, you have to correlate the result to put a little bit of a safety margin to appreciate that in what you have lost was not just bitumen, but it was bitumen and filler. But there is that is that effectively gives you a very accurate end result in any case. Okay, and the other, by definition, because the bitumen is burnt, you can't put other tests either, because asphalt is going between the atmosphere. So it's a compromise as a company, whether you are a research laboratory or contract, both options are available, and then it's a compromise. Do you want to recover your bitumen at the end? Do you want to have straight away the bitumen content through the phase out 50, or do you want a quick process and you use the formula to get a better understanding of the real bitumen content? We have gone through the bitumen content, but we still have our asphalt here, and we want to put it into different shapes. So how do we get it into either a slab, a beam, or a cylinder? Well, 3 different compactors, and I'm not going to spend much time on it, but the first and foremost is what we call the slab compactor. And again, it recreates a roller compactor. It allows you to make big slabs. And the principle is you have a load and a foot, and we take it this way, that creates that slab of asphalt at a chosen density. So you can effectively determine the number of cycles and the load that is applied, so you can actually measure the density.
How are you doing?
Then have another compactor, which is a press box. This one will give you beams as opposed to slabs. Very, very high-end compactor. I would say mostly. And
you're having a program, so you have to stay for it to be okay.
Research and advanced testing. I've never saw one. I've never seen one. I think it's reserved to elite. It gives you a high quality sample in terms of the Superpave. It's the research side of it. And the compactor, I'm not going to spend much time. We already looked at that.
Application of what? Okay, okay.
Quality cylinder. We now have the samples, shapes and size. And with the your samples.
You can send it to me on WhatsApp.
Giving flexibility for different types of software. When you've done that, you have go to saw, which then defines my wife saw this machine. I went with her in South Africa.
You need programming background.
She was testing that. You know, it was a day out for her. She was very pleased to see the laboratory. So we can.
Yeah, they'll teach you the beginner. They'll teach you the beginner slice.
Slice one. I know I'm going to be it. So anyway, the AutoSaw is a very precise machine, and we have 2 types. So we're going from a cylinder or prism or a slab, and we effectively that machine allows you to do the final shaping of your specimen. We have 2 types. We have the AutoSaw, which is fully automatic and enclosed, where the person cannot escape, or you have the multi-saw, which is a manual machine, and it's it effectively doesn't have the protection cover. But they both do exactly the same thing, and they will give you the same sample. It's like an automatic car and a manual car. Okay, there's no disadvantage in the quality of your product at the end. So you've shaped your specimen. There is the next stage, which is what we call the double wheel tracker. So you have got your either your slab or your cylinder, and the double wheel tracker is a very clever piece of equipment which allows you to simulate the rutting through a slab or through a core. You remember the rutting at the beginning of the presentation, which is effectively the road, the tires, the weight of the tires or the flow of the traffic creates effectively a dent in your road. Okay, that's the rutting you see it on every road everywhere in the world. And that machine effectively recreated. You've got the wheel here. I don't know whether we can see it so well. Yeah, there you go. There's the wheel there. And if you go up and down for 20 cycles, 30, 50 cycles, 50,000 cycles, I don't exactly know. And at the end, it will effectively create a dent. And that simulates the traffic. So it's a double wheel traffic, you've got two wheels there, and they are independent. So you're already doing at that stage, you're doing some performance testing in your laboratory. And at the end, you have all your samples that you started from the asphalt right down to the sample shaping, and you have the final machines. And I'm not going to spend too long on it, because first of all, at first stage, and that's a very, very long sentence, the Superpave program failed to define a set of performance-related laboratory tests that correlate well with the field performance of mixtures, and also simple to run on a widely available using standardized commercial equipment. What that means is the early Superpave lab field, the early program lab-based field simulations were not good enough, too complicated, and too expensive. So all these machines and all these tests which were designed, they were done by the elite for the elite. And none of us could recreate them in the lab. We could not afford to buy these machines. It was just too complicated, too expensive, and actually did not do a proper evaluation of your mix. And we are talking in the early 80s, early 90s. Okay, so it was like the birth of Superpave. So what they did is, well, we need to identify what are the main 3 or 4 tests that are the basic tests. It's like when you go to the doctors. It doesn't matter what's wrong with you. The first thing the doctor is going to do is check your blood pressure. Okay, and they will look in your eyes and your ears, and they will check your heartbeat, because this is like your dashboard on your car. On your car, you have usually a minimum 2 or 3 information: your speed, your engine speed, and your petrol or diesel or fuel level. Everything else is bonus. Okay, everything else is additional information that is necessary or useful, but you can't do without the first 3. And in relation to the project 919, that was exactly that. They said there are so many tests, we need to identify which are the main ones, the most important ones, the ones that will dictate everything else. Because we can't have 20 or 30 different types of tests. Nobody will ever adhere to that. So they said, we need to identify what are the tests, the main tests, the ones that we want everybody to do. Then, what are the machine? What is the machine that's going to perform these tests? So they wanted to bring it all these equipment down to one, make it simple, affordable, and available. And then, when we've got all this, we then do the actual standards. We do the manual. We give the people the opportunity to understand how it works and what to do with the machine. So let's look at how they identified the 3 main, because it was 3, the 3 main tests that will determine and dictate all the other tests. They created in US 3 tracks, one in Nevada, one in Minnesota, and one in Virginia. As you can see, geographically, they're very far away from each other and different climatic conditions. Okay, one was very cold, one was very wet, very dry. I'm not exactly sure which one's which, but they were different. They replicated different conditions. And they did so many cycles of trucks and cars, etc., around them. And eventually, so that took a few years, but eventually they had a real life understanding of what happens in the road. So they had to go back to basics. But they say we can't do a track everywhere around the world and just wait for the results, but that helps determine what are the main tests and how do we create the machines to replicate these tests in the lab. So the tests that they have identified were the dynamic modulus V, which is related to the strength of your asphalt, the flow number, which is resistance to repeated load and permanent deformation, and flow time, which is a static creep test. I'm not exactly sure what that relates to, but I think it's down to the deformation of your asphalt. So they decided, we know what we want to test, let's work on a machine that will do all that. And all this is the preparation of Superpave as we know today. So a machine that does all this, and the important part is it's one machine that runs all three tests, fully integrated, quick, simple, repeatable, and easy to use. And that was the simple performance tester. So the first multi-test machine dedicated to Superpave test in the early 2000s, sorry. But it was not a perfect machine. It only performed 3 tests. So it did perform the 3 main tests. But as it goes, you want it eventually to be able to perform other tests, to be a bit more versatile. It had a slow cooling rate, and some of the technology inside was locally made. So if you bought it and you were in USA and your hydraulic broke down and needed servicing, you had to go back to Australia because that's where it comes from IPC Global. So it was not actually the best machine because it was a good machine, but again, not good enough for the public. So we listened to the customers and made improvements on the later models. So we then created the AMPT, which was a replacement of the SPT, Simple Performance Tester, then became the Asphalt Mixture Performance Tester. Increased temperature range, designed to run not only the 3 main tests, but also another 6 tests, rapid cooling, and a greater loading capacity. Still, that area, you could easily cut your finger off if you're not careful. So the sample preparation area was not very user-friendly. It needed external air supply, compressed air supply, and the control panel was not easy to operate, and it looked already very dated when it came out. So it was still, there was opportunity for improvement there. So we listened again, and we made further improvements, and this is the last machine, which is the AMPT process. It's a researcher's choice, and it includes all the other advantages of the previous machines. Yet again, low temperature, very easy to operate, high performance, touch screen, and you can have an integrated compressor if you so wish. But it's still a very expensive machine because it's designed for the researchers. Okay, so Department of Transport contractors still didn't want to buy it because it was a little bit out of the price range. So these 2 tests are performed by the AMPT Pro and the AMPT and the SPT. But over the years, the Superpave testing process became very popular in many countries. The success of AMPT created the need of machines able to predict the behavior of asphalt. New testing machines need to be quick, easy, accurate, and affordable. And that's the most important part on that side, other performance tests have become more and more important. Okay, because of the popularity of Superpave, etc., it grew in use and popularity and in need. And then people started to actually give more importance to the other tests, not removing the first 3 tests in any case, but they just, get more and more important. It's like my mobile phone, our mobile phone. First, we wanted to be able to call someone and send a text message. Now it's not good enough. We want the internet. We want all the apps. We want it to be calculator. We want it to control our TV, etc., and play games. And that's effectively what happened there. They wanted more tests for their buck. So, these are all the other tests that became popular and necessary. All of a sudden, people wanted to be able to perform these tests. These are the main three ones: flow type, flow number, and dynamic modules, and then all the others. And I'm not going to go into these, don't worry. So performance testing machines, extended range. So we have the AMPT Pro, which is dedicated to the research because of its price, effectively. And we now have two babies, the AMPT Q, dedicated to quality assurance and quality control, and the Asphalt Q. AMPT Pro, we already went through that. And you can see the progression from SPT, AMPT Pro in 2017, and 2018, the AMPT Cube. This machine effectively, the AMPT Cube is a baby version of the AMPT Pro, but affordable to the market. There is slightly less capabilities than the AMPT Pro, but fully compliant to the Superpave standards. So effectively, it does what you need to do, unless you're a researcher and you want to go outside of the Superpave remit. Okay, it has the EMS technology, so you don't have compressed air to be able to run the machine. You do need a compressor to be able to control the very low temperatures, for example. But that depends on the type of test you want to perform. So it's a simple machine, okay, or simpler than the AMPT Pro. It has a 15 kilonewton load and a digital touch screen, integrated compressor, if you so wish, and a very wide range of temperatures. And it will perform exactly the same test as the AMPT Pro. It just will not perform research tests, which are completely outside of the remit. So this is the one for the contractors, effectively, okay, and the Department of Transport. If you want to test asphalt samples with the Superpave. And then finally, we've got what we call the Asphalt Cube, which is another version, and it's got the advantage. It's got a bigger chamber. So you can put bigger samples, effectively, you perform tests that you can't perform in a traction machine. And you've got a chamber that's available both sides, left and right, so it's easy access. And this one is exactly the same version, just a bigger chamber, yet enables you to have a greater range of temperature. And you can do this test. So in addition to all the other tests, you can do these tests as well, because you've got some big jigs in there. Or a sample traction test, 100 mil sample, whereas the other one is a smaller diameter. You can do all these in that big chamber. And that one is just a bigger one, yet again, when you want to have a greater range of temperature, which allows you to do yet more tests. Okay, so we went from a very simple, the SPT, simple performance tester, to the AMPT Cube and the Asphalt Cube, which are effectively what controls is focusing on for the greater civil engineering testing for Superpave. And you can see here the main difference between the Asphalt Cube and the Asphalt Cube Pro, and it's all down to the temperature range. And then a quick table to compare the AMPT Pro, Asphalt Cube, and Asphalt Cube. So there you have it. We have looked at Superpave, the fact that Superpave is there to give the construction companies and the laboratories the ability to go back to basics and test properly, performance test the bitumen and the asphalt that you're going to put on the road. And if you do that, you're going to have much better performing roads because you are done all the simulation in the lab, in a room that big, quicker, cheaper, and you can do all type of tests with this, as opposed to building a road and just making assumptions. Bitumen side and the asphalt side, performance side as well. So with our products and services, plus the promotion and education, you can help the ministers, Department of Transport, engineers and contractors to build roads that will last longer, reduce congestion, save lives, and save money, and to get roads like this. Thank you very much.
See you.
Yes, thank you. My throat is getting.
Yes, drink some water. Thank you very much, Ian, our presenter from Controls. And then, ladies and gentlemen, we'll open the floor for a few questions. We have some people online. So a few questions here and questions there. So we'll start with those here, right? Oh, we'll start with online. Okay. You will... Sorry?
I know that here in Canada. No, I just know that here in Ghana is larger for compaction and want to know the mixture. Is there any Superpave equipment here in the university?
Superpave, highways, we have Superpave. Highways has Superpave. So highways, as I'm sure, highways.
UTM from IPC Global. So one of the early, thank you. One of the early universal testing machines. If I just go back to, I think that's working. It's all right. I'm just going to speak louder. Actually, I can speak louder. If I go back to these machines, sorry. I'm going to do a little clicking. Too much. Can you please ask questions which are related to the last slide only? There we go. I did not talk about these because these are very early universal testing machines that did all the tests that we look at. But these are the ones which are complicated, expensive to run, not very easy to understand effectively. But they were very good, and they still are. Okay, but they require effectively a specific training or a level of expertise, and there is an experience with this machine effectively. In the labs that run these type of machines, you will have an oracle, one guy that knows it all. But if that guy retires or wins the lottery, etc., then you're in trouble because you need to train another person to use it. It's like an airplane pilot. Everybody can ride a car, but when you drive a plane and you pilot a plane, then you need extra training, etc., because it's just a different machine, even though it is a vehicle. Okay, Ghana Highways have this machine, which is a 15 kilonewton machine, which I actually saw a couple of days ago. This one is a 130 kilonewton machine, so just a greater capacity. So yes, the answer to your question is it already exists, and it exists. It's been in Ghana for at least 10 years, right? The UTM 15. Yeah, highways. Yes. Why is that? 15. But the purpose is to have other machines like this and this to democratize it so that it is affordable and available to all the other labs. Because effectively, Marshall came in and everybody now does Marshall. Effectively, Marshall will disappear. It's not my decision. That's how it's going to be. It's like the old Nokia. It won't exist anymore.
Why is that Marshall? Okay.
Don't listen to him. But you will go because ultimately Marshall, as I explained earlier on, does not cover all the areas, and it doesn't give you the ability to foresee how your rush out is going to predict. What it does, it's an estimation. There is nothing like performance testing to know exactly you got it right there. Okay.
Any other question online? Do you have some friends online who wants to? Any friend online to ask a question? Steve, can you please go on? Unmute and go on, please. Steve? Steve, please unmute yourself and ask your question.
Or type it.
Or you want to type it, that'll be fine. Can you hear us? Okay, the next question. Anybody there to ask another question? Okay, any friend from the room here? Yeah, no, it's for businessmen and both. All engineers are businessmen.
My name is Michael. I want to ask about the Pavlab 50.
Yes.
Yes, you did it. I don't know whether it worked as an extraction machine because it's if you want to get your component or your materials, I want to find out how it separates the component for you.
Yes.
It separates it. So with the aggregates and then the final, it separates all for you.
Yes. You put your asphalt samples, and at the end you will have aggregate, bitumen, filler, and salt.
Okay, thank you. My name is Leslie. You said Marshall will disappear. We're going to be testing for flow and stability and training. I saw you mentioning some other parameters. So which standards, which codes are we going to be guided by preparing our specification for this?
The Superpave process, Superpave has its own standards. These are new standards that include the performance testing, because performance testing did not exist in the past, or certainly not up until the late 80s. That was reasonably standards.
Okay, but in Ghana, we are guided by federal standards. We can't just adopt Superpave standards. We have to go through a process. So it's not ASTM, it's not ASTM.
Yes, but is it that everybody in America, the dots, are they all using Superpave now? Yeah, or no?
South Africa, in Europe, it's all fully adopted. South Africa, fully adopted.
Sorry, I know that in Brazil it's increasing more and more.
Yes, yes. Africa is kind of one of the latest areas where Superpave is being used.
We can know the appropriate ASTM standards. Yeah, and we can also have
No, he was asking if you can know the appropriate ASTM standards, then go to I'm sure the ASTM standard, they just the title. The ASTM is something.
Yes, there are. It's ASTM, I don't have them. So they're all that many. They're all that many because they were down to the bitumen side and the asphalt side. Because it doesn't consider the aggregates so much. And every test, obviously, I'm going to start thinking again. But if you look at the different, thank you. You look at the different tests that we highlighted earlier. So these two are specific to one standard. Well, actually, there is a VN version and an Ashton version. And then you have other tests, and you have a different standard for all these tests because the standard is effectively a set of procedures that you have to follow to be able to perform the test. So if that is a test that did not exist in the past, you effectively have to create the procedure to perform the test to get these results, which give you information, the data that you need. So there are many more standards, but they all revolve around these tests. And again, not every test is relevant to your country because of the climatic conditions or the road conditions that you expect to have, etc. You as a Superpave testing lab, you do not need or have to perform all the tests. It's like a bakery. The bakery will not do all the cakes that are available in the world. You just decide to stick to some because that's what your customer base wants.
Okay, any more question here? Do you have some of our friends online? But let me ask a question. It's to everybody. The question is, why are we interested in Superpave? Why are we doing Superpave? Are we doing Superpave because we think that it will help us, set up one of our route? There's a road service. Let me finish it out, Michelle. Because now, I don't know if some of us we do observe what goes on our road. Check intersections. Check speed hump areas. Check areas closer to toll booths. These are areas that are having serious dynamic impact on our road surface. And they are very related to the roads. So once we are getting surface erosion, surface being eroded gradually and water gets infected into it, we'll have problems. So apart from Superpave, I think that we need to look at our design philosophy again. I personally, I don't like speed. I'm not interested because it's a deteriorating effect on our. If you check, you can do a research. Walk through the corridors that we have these features there. You see that the roads are highly deteriorated. So we can do Superpave. But if we are not injecting the proper features on certain areas of our roads, and even the road designers say go 60, you want to go 100, why? These are for a particular purpose. So it's not about we having Superpave. We can have Superpave, and yet we can still destroy our roads. So we do Superpave, and then try and put up good behaviors on our pavement as it will help us. So
sorry, I will add to maintenance.
Maintenance, okay, that's fine.
If you design with Superpave, you have a Superpave pavement during 2 years, but you don't have maintenance, then that's the thing. The main thing here in Ghana, I think it's
we'll have to have Ghana Highway. Yes, because they are. Is it working? Okay, please go on.
It works in the moment. Yes. I mean, why do we design vaccines, for example? It's because there is a disease. Because we need to cure the disease, or we need to have, the COVID vaccine doesn't cure you from COVID. It stops you from catching COVID in the first place. And why does Superpave exist is because, as I went through in the presentation, in the US, they say, well, we can't carry on like this. We know the roads are failing. And not only we know that they are failing, we understand why they are failing, what makes them fail. And based on that, they identified where we need to find a test that will replicate the rutting, and we need to make a mix which will allow us to have a greater resistance to rocking or thermal cracking, etc. And then when we have made that mix, we test it to see if we got the formula right, just like a cake. You have to have the right ingredients, but you also need to put the right quantity of ingredient at the right stage of your recipe. And Superpave is exactly doing that process. And then at the end, you test it. So effectively, I give you a piece of the cake and you tell me if it's good. That's effectively what the Superpave machine does.
Okay, I think yes. Okay, please.
Superpave and things. Have you got any from that? I don't seem to be able to identify that. I
think, well, I can't give you that answer because I don't have this answer. From a theoretical point of view, if you know what the stress, the load, the speed, the frequency your asphalt is going to be subjected to, whether it is a car, a motorcycle, a truck, whether it's an urban road or an airfield, effectively you will be able to identify the best mix for your application. If you know what are the outside factors that are going to affect your pavement, then you can factor them into your mix and do the performance testing. So I think it doesn't really matter what the application is, because we're looking at the early stage of the mix. If you have all the constraints, all the things that you want to avoid, then you consider that in your design mix and accordingly in your testing process.
Okay, so I have you on the first.
That's a good question. Since Ghana Highway Authorities have your group,
Yes.
I presume they can do most of the tests that you are talking about.
They can do a few of the tests, yes. Mm-hmm.
So aside of the Marshall and so on, what are they doing? What are they testing?
But they're doing 4-point bending. Well, right now they're not doing all of the tests because some of the equipment is no longer in.
Don't let him kill you.
Okay.
I'm asking you.
Unless we are telling us what we have already delivered to them and what they can be done.
I saw the machine 2 days ago. I know what needs attention, what is working, and we're talking to internally. I'm already online with Australia, where the IBC guys are, and they're working on that situation. So we are addressing. Okay, but in terms of all the tests that Ghana Highway Authority is performing, yes, Michael is the better person than me. I know what is happening with the machine itself.
Okay. So it means that they will bring out that's right. Tell us what you can do. Once you go the Superpave way, then you all come in line. Okay. I mean, I'm sure people would like to go the kind of lab available and this lab is doing excellent. I know it's only highway where you can go to Asphalt, guys. This is where they are operating. Oh, definitely.
Yes.
The question here.
Well, no, I was just suggesting that we take a snapshot of all these questions on the list. Because a lot of them,
Okay.
I don't have a capability.
All right.
So I say,
Okay.
well, not the engineer.
Okay. Yes, Control has a rep in Ghana, right? And that's the Tectonics Engineering and Comfort Limited. Okay.
Correct.
All right. So so you pick some of them. These are more technical,
Too technical for me, but we can answer.
Unless
I just want to answer myself.
Let me just read one so that if we can discuss the few here. Let me read one or two questions here.
Somebody's raising us.
Okay, Abdul Rahman Dauda, can you please talk?
Yeah. Good evening. Everyone, and I missed most of the presentations. I just came back from school. I was logged in, but I heard the presenter saying, in Superpave design, he was alluding to the fact that you factor in the speed, the stresses being subjected on the road, and other factors, which I didn't hear him mention, like, what did he mean by other factors? Is it the weather conditions and other stuffs?
Yeah. I was talking about, you mentioned what goes into Superpave design.
Yes.
And he said he heard you say other factors. So he was asking the other factors, do you mean environmental conditions?
Absolutely. Well, the beauty of asphalt testing within the Superpave process is you are not only measuring the load, the frequency, but you are also factoring in the change in the frequency, the change in temperature, in some cases a change in humidity. You can do tests in water bath, for example, the double wheel tracker. You can do the test dry, and you can do the test with your sample submerged in water and in very hot or very cold air. So yes, it does take effectively the climatic conditions into consideration, which is why it is considered a performance test, which is a simulation of real-life conditions. And you cannot simulate real-life conditions without taking the atmospheric conditions into consideration.
Okay, okay. Thank you very much.
So, let me see. Someone is asking, how do you simulate and test for asphalt concrete on a structure with high water table? I don't know if anybody can give us. Yes, that's this question. I don't know if you can share our opinion. Yeah.
You have to like a modular scenario. Get from the wearing cost.
Yeah, so just what you don't want
So,
all right. So I'm thinking that people have asked here, which I think is beyond our scope here anyway.
correct.
Yes. So, can we take one or two questions here so we can sign off? Ladies, it's only we should talk now.
Right, so the second question, how do you design asphalt concrete such that it can withstand heavy loading within a curve or roundabout? Again, it's all about knowing what the stress of the say again?
Who's Michael here? I will give him Michael. We'll give him a chance.
We're listening to you, Michael.
Okay, Michael.
Yeah.
Please go ahead.
Okay. Good evening, all. If I may say, good evening out there. It's evening almost here too. That question that you wanted to say, how do you simulate a pavement in a swampy area or waterlogged area? Did I get it right?
Yeah.
If you want to test performance of a pavement, well, my name is Michael. I'm speaking out from Canada here. If you want to actually get the idea how your pavement will perform if submerged, you could do that utilizing the wheel rod tester. In this case now, you're not going to test the pavement sample dry, but you can submerge it in water. You can actually freeze the water, or you heat the water up to a temperature of simulating the temperature you have out there. If your temperature is 58 degrees Celsius, considering the binder high temperature that you have, if it is 64 minus 28, you can subject the heat of the water to 50 or 64 degrees Celsius and submerge that pavement sample while you run your wheel rod test. So that will give you an idea how that pavement will behave in terms of flooding. If the pavement is flooded during a high summertime, how it will perform under stress and loading. So yeah, this is the wheel rod tester. So you can see the wheel rod on the left, on the right, where you have my right being your left, where you have the wheel on the sample. So in that case, now you're testing it dry. So you can actually flood this wheel rod tester with hot liquid water or cold water, and then simulate what will happen to that material during flooding and high temperature or low temperature. So I think that answered the question a bit. Or if there's any more thing you want me to clarify, I'm all willing to assist Jan.
Thank you, Michael. Michael, sorry to interrupt you, but Michael works for a cash out in Canada. He runs his own lab of bitumen and asphalt testing under Superpave, and he's using a lot of controls equipment. So ultimately, Michael is the ultimate expert in this type of test. I can talk about the equipment to some extent. Michael uses the equipment. He has many years of experience and is extremely kind to spend his time today from Canada live with us to support us. So thank you very much, Michael, for joining us and providing the support.
Right. So you have Steve there. Steve, can you come up with your question, please? Or meet yourself. Hello, Steve.
Steve, if you can hear us, you need to unmute your computer.
Okay. Now, there was one question you read there. Can you, talking about roundabout stuff, where is it? How do you design asphalt concrete such that they can withstand heavy loading within a curve or roundabout?
This is effectively, and I'm sure Michael would want to chip in at that stage as well, because he knows way more than me. But whether it is a roundabout or up mountain or down in a mine, etc., the point is the fact that it's on the roundabout is just a different state of stress on your asphalt. So if you know what stress or what condition it will be subjected to, you can then replicate it in the lab with your mix. And the fact that it's a roundabout or a curve is the end result.
Yeah, but let me just add that locations like curves, beds, where we have a lot of braking, these are very critical sections for either it's asphalt or not asphalt, because you have different stresses coming. You know, it's not like the straight road. So when we are designing our pavement, it's not only the asphalt section. If you look at the structure itself. And here, materials are very key. You know, those areas I see the forces are 3-dimensional. That's why these people introduce geosynthetic products within the pavement structure to take care of some of these forces. Okay? So we are still learning, and I'm sure you'll say.
I do think it's straight pavements. The road line can, but when you get to the curves and those things, those roads cannot. So sometimes they use the temper or picking those small ones. The compaction is the issue of compaction.
Yeah, so that's why Jan was saying, if we're able to define the necessary stresses within the various sections, whichever location we want, they are very important. I'm sure that can also influence the use of the equipment for compaction. So, but apart from that, the geometry should be there, but the structure itself is also very key. Materials that we are going to use for construction is also very key. If we know that curves, intersections, where we have high breaking points, these are areas that are very critical and they deteriorate road faster. Exact points, those areas, traffic lights. So you see this in Ghana, we will be there highway or urban roads, feeder roads, they have their roads, and the community come, no, let's put speed humps. And we will put speed humps. Quite not saying engineers, you are not serious. Well, you're quite in 2 years or 3-6 months, the road is deteriorated. But they don't know that it's part of that. It's their behavior. So we need to educate ourselves and let the public know that it's one way having a road, and it's one making sure it functions properly. Okay. All right. Yeah, you want to say your last word?
Well, there is one third question, which I think if Michael is still on the line, he will be able to answer.
Okay.
What is? Can you hear Michael? Yeah.
Yeah, I'm here.
Okay. Do you? Sorry, can you show the? Yeah. What is the effect of chloride and sulfate water on asphalt concrete, and how do we prevent any damages from those chemicals? I think maybe this is something that you would be extremely able to answer.
How to prevent asphalt concrete from damage from heavy chemical?
No, it's the effect of such chemicals, sulfate, chloride, water on asphalt concrete. That's one. And then how do you prevent any damages from those chemicals?
Okay, I think the first thing first is to those chemicals really have effect on, they are very detrimental effect on on asphalt concrete pavement. Diesel too, that you use for trucks, they can eat up your pavement. So the thing is, you can engineer, like when you know you have such kind of problem around that area, you characterize your bitumen, characterize your binder, trying to add certain additives that will prevent corrosive attack from chemical. If it is salt, in salty area, you try to find a way to counter it. So it's basically adding additives and then trying to prevent it. So it goes back to you characterizing your bitumen for that area. And then remember that by the time you want to select your bitumen, you think about temperature. When you think about temperature, you equally go to that area. Like in the riverine area, you know that close to the ocean, you have a lot of salt water. So the kind of characterization you give for that particular area will intend, you have to think in your mind to resist attack from salt water, attacks from corrosive activity of every other thing. So you will engineer your bitumen to counter that. And that's why Superpave is good, because it gives you the opportunity and equipment to fingerprint what you have. I think that's the way to prevent that. There's no two-way about it. It's just to add additive to prevent it by engineering it.
So thank you very much, Michael, for your intervention. Our last question here, then we can sign off. Anybody asking the last question? Or I would, engineer past president, you haven't spoken. That's our.
Anybody who wants to place an order? Good job.
Okay. How much? Exactly. The man is bold.
I can give you a quotation. I can't tell you how much it is. For this type of equipment, there are various variations, various options, etc. So I can't give you that information like that. But hopefully, surely, if you want to talk to us, talk to Tectonics or myself, we can provide you a quotation. But we would need to identify exactly what is your need. Okay? But for sure, it's not the price of a mobile phone. You're talking about a very important piece of equipment in your lab, which requires some training, and it's a long-lasting piece of equipment. So it is an investment, and that's how, from a sales point of view, my speech is always going to be the same. It's an investment in your lab, but it's investment so that you will save money in the long run, or the institution will save money, etc. So it's all to the benefit of a better road. It's just like a vaccine, etc., or preventive medicine.
So you get exactly. Okay. It's a big man. It's a big brutal man.
I know, Leslie. I know your wife very well.
You know him.
I met your wife yesterday.
I know him.
Yeah, I know Mrs. Angela.
Hey, he's a big brutal man. Yeah.
Availability of spare parts and consumables, because you use some machines and after some time it's phased out, and it's like you have to throw the machines out.
No. I mean, these machines have been in the field for a few years now from controls. But we effectively, because as we know, it is kind of the birth of Superpave in Africa, etc. Our equipment has all the spare parts, and you can talk to us, you can talk to Tectonics. I can give you references of our agent in South Africa who is only buying Superpave equipment. I mean, South Africa is fully Superpave adopted, and all the major asphalt producers, they are using not only Superpave equipment, but controls equipment, the Asphalt Cube, Asphalt Pro, they all have their Durable Tracker, etc. And we have all the spares and the maintenance available for this. So don't worry about that. It's like your car. If your car is less than 20 years old, you're going to be okay. And with the machine, it's exactly the same.
Thank you. So I asked our immediate past president to give us one or two statements, then we'll sign off.
Thank you very much. It's good listening because we are trying to standardize testing procedures at pavements in West Africa. And we're doing this because we're trying to improve the infrastructure in West Africa. As a matter of fact, we're having a meeting in Abuja at the ECOWAS Secretariat. We're looking at various countries trying to come down with standardized, specifications and then also the equipment for testing. Because when you're doing, we learned from the part where we're doing a power project across 3 countries, and the specifications were different. That obviously, and the equipment used was different, so that obviously affected the cost of the project. So we're trying as much as possible to ensure that we have a standard thing in West Africa. Along there, I've got the francophones on board, so that's major victory. So it's important to listen to you, and then I talk to you privately about costs, and then we'll be able to give a good message of peace in Abuja. Thank you.
All right, thank you very much.
Okay.
I conclude that.
Yes, well, first of all, thank you very much, everybody, for coming today. I know it was late in the day, and it's now quite late in the night. I hope it was fruitful information, good awareness on Superpave. It's very important for us. It's the second time that I'm doing Superpave in Ghana. The first one was a few years ago. It didn't have the same impact and the same interest. I'm very, very pleased to see you here today, but also all the people online and the questions which are testimony to the interest that Superpave and Asphalt performance is, the awareness of this. So I'm very pleased to see that, and a special thank you to Michael from Canada, who's obviously joined us live today to support us. So I hope if you have any questions, obviously, if you haven't got my card or the Technologies card, I can distribute them. I've got them here, and we will always be happy to support you either directly from controls or via Tectonics. Do not hesitate. If they can't help, I will. If I can't help, they will. And the idea again is to help the Ghana road infrastructure to have access to better roads, longer lasting and cheaper structures. Thank you very much, everybody.
Thank you very much, Jan, for coming. And I also want to, this is a Civil Technical Division's program, and I'm a chairman there. I also want to take the opportunity to thank you for coming. We went off for a very long time because of COVID, and we are coming back. At least we miss ourselves in terms of our in-person meeting. But the in-person meetings are one of the avenues that we network. And now we've not known ourselves for over 2 years now. So we'll be starting our in-person meeting there. So anytime that we put out the notice, please, I beg you to be here. Okay. I'm sure the next 2 months we are planning on having a forum for 7 years. What we can talk. Let's see how we can build the professional. The challenges that young men are facing, young men are facing. And then the challenges that we are facing in the industry in general. Okay, so we have plans for that, and we'll give out an announcement in people. So thank you very much for coming, and see you back on. Let's speak. There's a snack there, pick and coffee. I say always pick and coffee, so pick and coffee, and then walk downstairs quietly. Thank you very much.
Hello, sir.
Yeah, we are off.
Oh, okay. Yeah.
Thank you.
Okay.
If you are, in case you are not kindly do the question. I'm exploring.